All right, Unit 2, Section 12 is box plots. So box plots are graphs that help us better picture how your median and your quartiles are spaced, as well as helping us focus on more typical data values in the middle of your data set. So they give us more emphasis on the middle 50% of your data. So your box plots basically have this box in the middle, and they have basically what's kind of called your box and whisker plot. So they have a box in the middle 50%, and they have whiskers on the end. So they show 50% in the middle. So they basically split them up into quartiles. Your first quartile here, your middle 50% here and out here. So when you find that inner quartile range here, your quartile 1, your quartile 3, that's where you find it here. So to draw a box plot, you need your 5-number summary for your data set. You're going to find your minimum, your quartile 1, your median, your quartile 3, and your maximum. So your minimum is your smallest value. Your quartile 1 is your median of your lower half of your data. Your median is your middle value, your quartile 3, and your maximum. So sometimes you can draw your box plot horizontally, and then sometimes you do it vertically. So you've got your median in the middle. So you have a box and you've got a line in the middle for your median. Your third quartile, quartile 3. So they'll usually write it as Q3. Quartile 3 up here or on the right. Quartile 1 is on the bottom half of the box, and then your maximum and your minimum. And so that's what a box plot looks like. So on this one, this is that dental office salary example that we did last class. So all they want you to do is they want you to look at this one. If you look at the data from the class, you can kind of see this, but we're just going to kind of look at this one and estimate it. So on this one, oops, let me get a pen here. So right now your minimum is right here. So this one is 18,000 is your minimum from this. Oops, not 180,000. Come on, I can't draw right. Let me try that again. So let's do this again. So your minimum is 18,000. This is your minimum right here. And then your quartile 1 is right here. That would be right here. That's at about 30,000. And then let's get another color. And then your median is right here in the middle. That's this number right here. That one is at 48,000. So this is our data from the other day. And then our quartile 3 is right here. That was at 70,000. And then when we put in the dentist salaries, our maximum was out here. That was at 160,000. That was our maximum. So here is our horizontal box plot. Okay, so number 2, it says the following represents 15 commuter times for workers who live in Austin. They want you to find the 5-number summary. So we have 15 workers. So they want you to find the 5-number summary. So we're going to find the median. So we're going to find the number in the middle. So if I have 15 workers, 1, 2, 3, 4, 5, 6, 7. So this number right here in the middle, this one, 1, 2, 3, 4, 5, 6, 7. This number here in the middle, that's going to be our median. And then this one is our minimum. This number is our maximum. And then between our quartile 1, so we're going to look at these numbers here. Let's see. So there's 2, 3, 4, 5, 6, 7. So 1, 2, 3. This is our middle number of those 7. Here's these 7 here. 1, 2, 3. Here's our middle number here. This is our quartile 1. This is our quartile 3, 10, and 30. So there's 7 numbers in this bottom half. There's 7 numbers in this top half. So we're going to basically split that in half again for those. So there's my 5-number summary for that set. Okay, this time I have 20 commute times. So I need to find the middle 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the middle. So if I average 20 and 20, my median is going to be 20. So there's 10 numbers here. 10 numbers here, so I'm going to have to split them in half again. 1, 2, 4, 5. 1, 2, 3, 4, 5. And so then the middle of 15, this is my quartile 1. This is my quartile 1. So my middle of 15, quartile 1 is 15. And then 40 plus 45 divided by 2 is going to give me 42 and a half. And then that's going to make my minimum 5, my maximum 85. Okay, so as you can see, I recopied 2 and 3, the numbers from my commute times for Austin and my commute times for Houston, and I want to make a vertical box plot, so meaning I want them to go up and down. I want them to look something like this. I want them to go up and down. So for Austin, I'm going to do blue. So I basically need to make dots on all of these 5 numbers. So for Austin, let's see if I can do this. I need to make a dot at about 5, 10, 20, 30, and again it's 60. And then I need to make a box around the middle 3, make a line, and here's my whiskers. So that's for Houston. For Austin. And then Houston, I need to do at 5, and I'm going to do the best I can on my screen. 5, 15, 20, 42.3, and then 85. So then I need to make a box around my middle. And there's my whiskers. And that is my box and whisker. Oops, let's connect. That didn't quite connect. Those are supposed to connect. That's my box plot. Also sometimes called box and whiskers. Okay, on A, they asked for, was the shape, was it similar or different, symmetric or skewed, and what does this mean about the commute times? Okay, so the distribution of the commute times are both skewed to the right. So picture kind of turning the graph, if you will, to your right or whatever. So your distributions were basically both skewed right. Okay, so basically like a picture you're turning your graph to the right. So picture this is the left, this is the right, because your 0 is over here. This is your left and this is your right. They're basically both skewed right. And then basically there are higher commute times. There are higher commute times. In each city. Okay, so you have a few outliers, okay, which basically gives you kind of like your tails or your outliers. So that's kind of what pulls that tail out. Okay, so both of them, they're centers. If you look at both of them, for both of them, oops, I need a pen. So for Austin, your median was 20. For Houston, your median was also 20, okay? So when they ask for center, they're talking about median in this case or whatever. So both centers had a commute time, so the same. So basically, your centers were the same. Okay, so C says, variation. Is it similar or different? What does this mean about the how the commute times vary in these cities? So on this one, there's more variation in the Houston communities, some with higher times that are given. So this one's spread out more. So there's more variation. in Houston with higher commute times given. Okay, so most statistical software has an option that will flag potential outliers in the box plot. Consider the following box plot of the dental salaries, this time with 2 flagged salaries as potential outliers. So here's your 2. These are the actual dentists. These are basically all your office workers. So a lot of times they'll leave the dentist out because there's basically, this is the gap in salaries. So a lot of times they don't want to include the 2 dentists in the box plot, because if I make a box plot and include these 2 dentist salaries in here, then it looks like if I make one big long whisker, it looks like 25% of your staff has salaries in here when they really don't. So whereas 25% of your staff has salaries in here, that stops at this point right here. Whereas if I extend it all the way down here to this dentist, you think, oh, wow, you have staff in here that gets this high salary in here, whereas they really stop at this point right here. Whereas it's deceptive if you make a line that goes all the way to here, you think, oh, wow, they pay somebody in their office $130,000 or $100,000 when they really don't. It's just because you have these 2 dentists in here, whereas that really stops here. 25% of the office is in here, 25% in here, 25% here, 25% here. So notice that the whisker on the right only extends to 74,000, which is the highest value that the software considers a non-extreme. They decided that the 2 highest salaries are too extreme to be considered for the rest of the data. So these 2 are extreme, and they don't include them in the general part of the graph. So they put them there as outliers. So we're going to show you how to calculate those on the next screen. Okay, so in order to calculate outliers, you have to find what's called an outlier fence. Basically, this is kind of like a boundary, so that anything that is above or below these numbers would be considered an outlier. So it's considered a fence. So any data value that is farther than 1.5 times the interquartile range below or above quartile 1 or quartile 3 are considered potential outliers. These we call cutoff outlier fences. So the lower outlier fence is quartile 1 minus 1.5 times your interquartile range. So anything that is lower than this value is a potential outlier. So your upper outlier fence. So these are not, this calculation does not get you an outlier, it gets you an outlier fence. So any number that is above or below this number is an outlier. So this basically just gets you kind of like your boundaries. So it basically kind of tells you like a cutoff grade. So it's kind of like in school when they tell you that like 70 is the cutoff grade for passing. So it tells you that like 70 is your cutoff grade for passing. So anything below a 70 would be an F. So that's kind of, think of that what an outlier fence is that anything above or below this is considered an outlier. So statisticians make a subjective decision as to whether these values are actual outliers, they're potential outliers. So we're going to figure that out on the next screen. Okay, so here you have the set of data from the dental office. You have your minimum, your quartile 1, your median, your quartile 3, and your maximum. Okay, so we're going to find my interquartile range is just the difference between your quartile 3 and your quartile 1. So your interquartile range, remember IQR is your quartile 3 minus your quartile 1. So that's going to be the difference between these two. So that's 69,750 minus 31,750. So that's going to give me $38,000. That's my interquartile range. So then 1.5 times that amount is going to give me $57,000. So to get my lower fence, I'm going to do quartile 1, which was my $31,750, and I'm going to subtract that number that I just got, $57,000. So if I do $31,750 minus $57,000, we're going to get negative $25,250. So if I have any salary in the office that's below that, that will be an outlier. Okay. So and obviously you don't have any salaries in your office that are below negative $25,250. So there's no outliers. So there's no salaries below this number. So you're good. Okay. So the upper outlier fence, you'll do quartile 3, which was the 69,750 plus my 57,000, which is going to equal $126,750. And so that tells me that anything above that dollar amount is an outlier. And so, yes, so they both, so remember you had 2 salaries. So the 2 dentists, check yes, are outliers. So the software did flag them correctly. If you go back and look up on your screen, there were 2 dots that were outliers. Those 2 dots on the top of your screen were outliers. Okay. It says recopy your 5-number summary for the Houston commute times from problem 3. Okay, so here's all of your numbers. So my minimum was 5, quartile 1 is 15, median is 20, quartile 3 is 42.5, and my minimum is 85. Okay, so my interquartile range is 42.5 minus my 15. That's going to give me 27.5 for my interquartile range. Then I want to find my 1.5 times my IQR. That's going to give me 41.25. Okay. Then it says find my lower fence. So my lower fence is going to be my quartile 1, which was my 15, minus my 1.5 times my IQR, which was my 41.25. That's going to give me negative 26.25. And they want to know, are there any Houston commute times that are potential low outliers? So I need to see if any of these numbers are below negative 26.25. And my lowest number is 5. So there's nothing below negative 26.25. So there's no low outliers. So that's it for that one. And then my upper outlier fence, you're going to do your quartile 3, which was my 42.5, plus, again, my 41.25, is going to give me my 83.75. So now I just need to look up here, and I need to see if there's any of these numbers on this list up here that are above 83.75. And so there's only one number above 83.75, which is the 85. So this is considered my outlier. So now if this is considered my outlier, okay, my 85 is an outlier. So this is now an outlier for this. So this is basically going to be in my box plot. This 65 is going to be where my box plot stops. And then this is going to be a separate dot. So the 85 will be a separate dot. And then, so on the next screen, we're going to redo this. So your box plot is going to stop at 65. So we'll talk about it on the next screen. And I'm going to draw a separate dot for 85, but 85 is an outlier. Okay, so since your outlier ceiling was 83.75, this is an outlier, okay? This is the only part that's going to be on your box plot, okay? So your maximum now for your box plot is going to be at 65. It's going to stop at 65. So when I go to draw my box and whisker plot, I'm going to do 5, 15, 20, 42.5. And now instead of going to 85, I'm going to stop at 65. Here is my box plot. I'm going to stop at 65 now instead. So I'm going to stop it here at 65. And instead, I'm going to draw a separate outlier at 85. So make sure that you draw your outlier separately. And then 65 is your new maximum. Okay? So make sure that you separate that. So kind of keep that, keep that, separate it. Okay, so number 7, okay, the following are lifespans of 32 different species of mammals. The 5-number summary is provided. So they're giving you the 5-number summary for all the data. So it says find the outlier fence. So my quartile 1 is 11 minus my 1.5 times my interquartile range. So 16 minus 11 is 5. So you're going to get 11 minus 7.5 gives me 3.5. So since 5 is my lowest number, there's no low outliers. And then for my upper outlier fence, my quartile 3 was 16 plus 1.5 times 5 is going to give me 16 plus 7.5, and that's 23.5. And so anything above 23.5, that basically is all of these. So all of those are outliers, okay? So you have quite a few outliers. So my new maximum is now 20. So instead of 41, I'm going to stop my graph at 20 now. So when I go to draw, I'm going to use 5, 11. I'm going to use 5, 11, 12, 16, and 20 for my 5 numbers. This is for my box plot. And then these are all outliers. So the 25, the 35, the 40, and the 41, these are all outliers. So my 5, my 11, my 12, my 16, and my 20, that gives me my box. And then my outliers, 25, 35, 40, and 41. There's my graph with my outliers. So you have to make sure that this data all goes in your box plot. That's your box plot, because these all are outliers, because anything above 23.5, the 25, the 35, the 40, and the 41, all 3 of these, the 25, the 35, the 40, and the 41, those are all outliers. Those all have to be written separately. You have to stop your graph now at 20. This becomes your new maximum. This is your modified maximum now instead of 41. You don't need to connect these anymore. These have to stay separate because they're outliers. These are your new outliers.